We'll do this question. First, we're going to highlight when you have a systems of equations where one is a line and one is a parabola. We call it a linear quadratic systems of equations because one's a line, one's a quadratic. And wherever you have the intersection of the graphs is the solution. So you can highlight both of those things on pages 386 and 387. And we have our first question. The number of students attending a leadership conference depends on the price change. It's determined that 20 students will attend the conference if each is charged $75. But if you increase the price by $10, one less student will attend. Now, that sounds like a max-min problem, right? This part right here, underlined in purple, would not have to be given to you. Because you've done max-min problems, you should be able to create that equation from that word problem on your own. And again, when setting these ones up, I like to think, okay, it gave me the 75 and 20, so that's going to be a starting point. Then every time I increase by $10, I decrease by 1%. So that's sort of how we set up our max-min problems. It's a lot of green in there. I'll erase it so we can see it better now. And the cost of running the conference is represented by this equation. 1,000 plus 75x. Which is kind of interesting, which means every time you increase the price, your cost increases. If you increase the price by $10 once, it costs you more. Just kind of, I think this is an example of a question created for a textbook that doesn't quite fit real life. But we'll work with it, and we'll see what we should do. So when solving for this, what we're going to need to do is we're going to need to graph. And one of the things that we need to get ready for and get good at with thinking about AP Calculus in grade 12 is getting used to using technology. So for this, what we're going to do is we're going to take out our graphing calculator. We're going to clear anything that we have in there. And we're going to write this into our graphing calculator. If you don't have a graphing calculator, you would write these equations into Desmos. Okay? On your AP exam in grade 12, you get to use Desmos or a graphing calculator. So, I'm going to put a set of brackets. I have, what's the first bracket there? 75 plus 10x. Close that bracket, and then it was 20 minus x. The second one, that's my parabola. And my second one was 1,000 plus 75x. And we know that the top one is a parabola and the second one is a line. Okay? So when we hit graph, we're going to want to see a parabola and a line. Get ready to be disappointed. Okay. Do you see the parabola and the line? No. We have a problem with our window. Now, a couple of things. You can hit the window button and just play around with random stuff until you see what works. You can hit the window button and use your brain a little bit and be like, ooh, y equals mx plus b. This one has a y-intercept of 1,000. So I should probably see at least 1,000. Some other things that your calculator has that are helpful is the zoom button. I'm just going to show you on the zoom button, like you can hit zoom out forever, zoom out, zoom out, zoom out, zoom out, until you see it. Okay? But one thing I like on the zoom button sometimes to try first is like, okay, if we would fit this on the screen, what would you do if you were a calculator, and what would you do? So I hit the zoom fit. Ooh, I see more of the parabola. I see more of the line. I'm really fussy. I want to see more parabola than showing up. I like to see like it come down on the other side. And I'm like, ooh, I'm feeling like it's really close to the top. It's a little bit claustrophobic for me at this moment. I don't want to start hyperventilating during my quiz or test. So I'm going to hit the window button, and maybe I want to go further to the right. It's going from -10 to the 10. How about 20? I don't know. I'm just trying things here. 20 might be nice. And I wasn't happy with how close it was at the top. 2,000 seems like just a little bit more. Oh, yeah, that makes me feel good. You can see the whole parabola there nicely. I can see the line. And now the solution will be where those graphs intersect. And this is where the calculator or Desmos is really nice. You just click on one of the graph and they'll put a big dot where they intersect, tempting you. Do you want to know that dot? You just click on it, it tells you. Super nice that way. Graphing calculator, everything you can solve on graphs is above the trace button. So we hit second, go to the calculate above the trace button. And number 5 is the intersection. Push enter on your first curve, enter on your second curve, enter to guess, and it will always find the intersection closest to where your cursor was. So it's going to find the one on the right when I push enter on the guess. And I know you can't just drag your computer screen to your notes, unfortunately, but I can, so I'm going to do that. There it is. We've got one solution at 10 and 1750. And what does this solution represent? This solution represents when the costs are exactly the same as the money you're bringing in. So basically you're breaking even if you're in charge of this, right? If you're running this conference just as a service, they'd be like, well, this will cause me to break even. I should increase the price 10 times, make it really expensive, $175 a student, only 10 kids will show up. It's not very good. And somehow when I increase the price, the whole cost of the event goes up $750 as well.
Costs more to have less people.
Costs more to have less people. But we can also be like, okay, let's find this other intersection point. So now my cursor's over there, so I'm going to have to hit the left button. Oh yeah, holding it in is definitely a better option. Okay, push enter on the first curve, enter on the second curve. You know what's the worst thing? Like sometimes you like to play live on the edge and say, I think I'm just barely over half. And if you're not, it goes and finds the same one you found the first time and you have to do it all over again. But I'm pretty sure I'm closer to the one on the left. When I hit the guess, yes, -5, 625. Which is really interesting. Apparently, if you actually reduce the price to $25, a whole bunch more people will come. Well, only 5 more people will come, but 25 people will come. And surprisingly, the cost of your conference goes down with more people. Maybe they run it in winter, and less people, it costs them more heat, right? If you have more people, the body heat, that must be what's happening at this conference. Yeah. Definitely.
I think some people have to pay the ass of the person who hosts just to get that.
Yeah. So in a word problem, usually it's important to analyze what your answers mean. I think we overanalyze this one because now we're making fun of the word problem, but that's okay. So this is what solving with a graphing calculator or Desmos could do. It can find your solutions quite nicely right away. Okay, if we go, we're going to do the second example. We're going to take out our highlighter again, and if you have 2 parabolas, we call it a quadratic system of equations. Most people don't use those words. Most of the time you just say, I have 2 equations with 2 unknowns. But in this case, like, I don't know what y is, I don't know what x is. So having 1 equation, I can't solve. Or if my solution is infinite, a whole bunch of points on that parabola. But having the 2, they might intersect. So again, we're going to go to our graphing calculator. I'm going to type both of these in. Y equals, clear this one out, clear this one out. And I had a 2x squared minus 6, x squared minus 6, and then a negative 0.5 x squared plus 4. And I'm going to do a common mistake and show you the common mistake. The common mistake is people forget that they have to use the negative button beside the enter button, and they just hit this, negative 0.5x squared, and it was plus 4. If you do that mistake, your calculator is going to get mad at you and say, when you hit graph, error, syntax. Check all arguments entered. You're like, oh, I didn't get into an argument with my calculator, I'm confused. But you can go to the go-to button and it should take you somewhere close, and it's like, oh, maybe it was my negative sign. If I switch that, now I can graph. And our window is somewhat of a problem again. Do those intersect twice? Or do they just touch once? Do they share, like maybe they share the same vertex? So sometimes what I also like is after I've done one question where I change my window a lot, I like to go to my zoom button again and go down to number 6 and get back to the standard minus 10 to 10, minus 10 to 10, push enter on that. Oh, that looks nicer. Okay, so let's find the intersection point. Second, calculate number 5 for intersection. First curve, second curve. Ooh, we are right on the edge. Do you think it'll go to the one to the right? Does your calculator think positively, or does it think negatively? Is it more biased to positive? Yes. Oh, it goes positive. Very nice. So 2, 2 is one solution. And we could find the other one. I'll just tell you because of symmetry, I know that it would be negative 2, 2, because parabolas are symmetrical, as your second solution. This one, because the points are nice, we might have been able to solve it without a graphing calculator. So what we're going to do next is we're going to turn to the examples on page 388, and I'm going to tell you, because you're going to work on these on your own, that some of them I want you to do with a calculator and some without. And most of them are going to be, because not all of you have calculators, you guessed it, most of them are going to be without. So question 1, I'll get you to do with a calculator. But above no, this is not the right question 1. This is your calculator one. This one, is non-calculator, and that'll be non-calculator as well. And we're going to do number 2 together. First of all, they give you a graph, which is nice. The number one thing most people do when they draw their axes is put it right in the middle. That's going to be a little problematic here because I can already see that this one is opening up as a parabola with a vertex at 2, 4. So I'm going to just choose to put my axes here. Wow. Hopefully you can draw a straighter line than me. I'm going to choose that so that my vertex at 2, 4 is there. Does that make sense? And it's opening up. In fact, I'm going to color code these. I'm going to make my parabola in blue and my line in purple. So 2, 4 will go over 1, up 1, over 1, up 3. So I can at least see most of my parabola. Sometimes you'll draw a scale and be like, oh, I don't like my scale after you've drawn it. So if you can think a little bit about it beforehand, it can be helpful. The purple one is a line. What form do we like to change lines to graph them easily? Y equals mx plus b. So I'm just going to draw from here a purple arrow. Can you see it's not hard to get the y by itself? You just have to move that 2x to the other side. And if you have y equals mx plus b, it's a good start to start with your y-intercept at 0, 7. Is that point also on your blue graph? No, the y-intercept of your blue graph was at 0, 8. Then you're going to go down 2 over 1, down 2 over 1, and draw your line. if you can solve a graphing question without a calculator, if that's what is expected from you on a quiz or a test, you will have a point, this one right here, smiley face, that point shows up on both. So that's why I like, on the blue graph, I labeled my vertex and over 1, up 3, I made those dots really big. And then with my slope on my purple graph, I started with my y-intercept down 1, and I made those points really big. And I'm like, there has to be a nice point where they both hit. And there is at that green one at 1, 5. And if you plug in 1 for x and 5 for y, it's the only point where both of them work. Question 2, we're going to do one of these together. Question 2 are all non-calculated. Nicka. Okay. And we'll do the first one together. I'm going to draw my axes sort of down here. I'll draw this one in blue. X squared plus 5, so 1, 2, 3, 4, 5. My vertex will be at 0, 5. Over 1, up 1. Over 1, up 3. Those are like key points. And I'll draw this one in purple. Its vertex is at 0, 7. Then over 1, down 1. Oh, there they are. Over 1, down 3. And again, by drawing it accurately on graph paper, there are my two solutions at 1, 6 and negative 1, 6. So I want you to finish question 1, circle question 2, finish the ones on question 2. I also want you to do question number 4. If you want to do more graphing calculator Desmos ones, also circle question number 3.